Let's look at this one. Alright, so they give you the velocity and acceleration equations, and they tell you the position when t is 0, but they don't give you the position equation. So part A says, is the speed of the particle increasing or decreasing at time t equals 5.5? Give a reason for your answer. So to determine if speed is increasing or decreasing, we have to check and see, do velocity and acceleration have the same signs or opposite signs? Because that's how you determine whether speed is increasing or decreasing. So basically we need to figure out what is the velocity at 5.5 and what's the acceleration at 5.5. So we have both of those equations. All we have to do is plug 5.5 into them. So if I plug 5.5 into this first equation, I get negative 0.453. Let me make sure I have it in radian mode. Yeah. Yeah. Okay, and then if I plug 5.5 into the acceleration equation, 1/2 e to the 5.5 over 4 times the cosine of e to the 5.5 over 4, negative 1.358 or 359. So velocity and acceleration have the same signs. At t equals 5.5, so speed is increasing. So that was worth 2 points. 1 point for knowing that the speed was increasing, and 1 point for knowing it was because velocity and acceleration had the same signs. How'd y'all do? 0. 0. Alright. Number 2, find the average velocity for the time period 0 to 6. So we're going to use our average value function, trying to find the average value of the velocity equation. So for average value, it's 1 over b minus a times the integral from a to b of the function you're trying to find the average value for. So for us, a and b are 0 and 6 because those are the endpoints of our interval. So we're going to do 1 over 6 minus 0 times the integral from 0 to 6 of our velocity equation. Even if you're going to type something in the calculator, you still have to show your setup. You still have to show what you're going to type in. You can call the velocity equation v of t. You don't have to write out the whole equation. You can just say I'm integrating the velocity equation, but you still have to show it. So then on the calculator, we would do 1/6, whoops, and then the integral from 0 to 6 of 2, whoops, I think I put 0.2, 2 sine of e to the, you can use t or x if you want to use t over 4 plus 1 dt, 1.949. You have to go to at least 3 decimal places on the AP test. So 1.949. So that was worth 2 points. 1 point for showing your setup and 1 point for the answer. So if you just wrote the answer without showing the setup, what you typed in the calculator, you would only get 1 of the 2 points. It's kind of like up here, if you just said speed was increasing but you didn't say why, you would only get 1 of the 2 points. Alright, letter C. Find the total distance traveled from 0 to 6. For total distance traveled, we integrate the absolute value of velocity. So we're integrating from 0 to 6. The absolute value of velocity. So you can do that in your calculator. 0 to 6. Absolute value, there's a template for it. It's right next to the number 9 is your template key. And it's the first template on the second row. 2 sine e to the t over 4 plus 1 dt. 12.573. So that was worth another 2 points. 1 point for showing your setup and 1 point for your answer. Alright, and then on part D, for the time interval 0 to 6, the particle changes direction exactly once. Find the position of the particle at that time. So we need to first figure out what time does it change position, and then we'll figure out what the position would be at that time. So to figure out when it changes position, I'm going to graph the velocity equation. I'm going to go type in 2, because it'll change position, it'll change direction anytime the velocity changes signs. So 2 sine e to the x over 4 plus 1. And I only want to look at the interval from 0 to 6. So 1, 2, 3, 4, 5, 6. So we're just talking about, let me see if I can change the color of that graph. Maybe make it a different color so it's easier to see. Okay. So I'm only concerned about this one spot right here, because that's the only one that's in the time interval that I'm looking at. 1, 2, 3, 4, 5, 6. Yeah, that one right there. So I'm going to find that, where that is. So I'm going to go Window, Zoom. Oh no. I'm going to go Analyze Graph, 0. And then I'll just put that little lower bound line to the left, and then the little upper bound line to the right. Okay, so it's at this time 5.2. Now, it's probably actually 5.2 and some more decimal places. So I'm going to store that value, because I don't want to use the rounded value to answer the next part of the question, because it's going to make my answer be off. I'll get what's called a rounding error, a compounded rounding error, if you use a rounded answer to find another answer. So if you go over to that little, to where it shows you the ordered pair for the, for that 0, it should turn into like a little open hand, and it'll say text next to it. If you press Control and Menu, it'll give you the option to do things with that. Oh, why is it not giving me the option to store? Let's see. Okay, there we go. It'll let you, I think, attributes, it'll let you change the precision. So like I can make it show more decimal places, which before you take the test, we'll probably set it to show more decimal places than what it's currently showing, because it only showed me 5.2, but if I expand that, I can see that it's actually a lot more decimal places than that. I can also store it. So if I press Control and Menu, Store is an option. And I'll just tell it what variable I want to store it as. I'll store it as T for time. And once it's stored, it turns bold. So it tells you that it's stored it. So that time is 5.196 or so. That's when it changes direction. So we want to find the position at that time. So they gave us the starting position. When t was 0, it was 2. And so we did a problem like this earlier. To find the position, you take the starting position and you add the change in position, which is the integral of velocity. Over the time period from when you started at 0 to this time here that we just found, which I'm just calling it t, because that's what I stored it as in my calculator. And as long as I write that down on my paper, it's okay for me to use it in my integral over here, because they'll know I'm meeting that value there. So I'm going to go back to my calculate screen, and I'm going to do 2 plus the integral from 0 to t of my velocity equation, which I actually have stored in my calculator, right? Because that's what I graphed here, was velocity. So if I don't want to type that whole thing again, I can just use the var button, the variable button, and just put F1 right there. And it was F1 of x dx. So 14.135. And that part was worth 3 points, I believe. Yeah. 1 point for finding when the velocity is 0, 1 point for showing your setup, and 1 point for your answer. So 1, 1, 1. So how'd y'all do out of the 9? You got 1? 0? 1? 2? Where'd you get your 2 points, Teresa?
I got A and then I got B, except like at first it was wrong because when I calculated it was in the 3s and I
Yeah, we'll make sure. I'll make sure before the test that they're all set to the right mode.
And mine, I can't graph it. The graph is short.
Here, let me see it. Let's look back at the 2009 test, number 1. Oh, you have to use x here. You can't use t. On the graph, you don't have a choice of variables. You have to use y and x. There you go.